In this tutorial series, we'll be looking at a game called Nightstorm, and it's available on Steam, and we'll be trying to replicate something like that using Playmaker. So I have this assets from kenny.nl. I'll put a link for these assets in the description below, and you can get them from kenny.nl, or I can just leave a Unity package file, but it will be nice if you download from their website since it is free anyways. And all these files are from kenny.nl, and the talk animation is from Mixamo, and basically it looks like this. And I'll put I can't put a link to the animation per se, but I can just, like, you can refer to this animation and find it out in the Mixamo animation library. This is the same animation that the Nightstone game uses. It's weird that, like, I could identify that animation by looking at it, because I've been, like, hunting for animations for a lot of projects before. So in this tutorial, we'll be looking at how to basically make the character move, and I've just pulled the character into the scene, and make sure you change the animation type of the character to humanoid. And I've not made a animator controller, so I'll just create an animator controller, and I'll say player. Here I would like to get all these animations which I've not made them humanoid, so I'll just select all of them and use them as humanoid. So once I have that, I'll open up the player animation controller, animator controller, and I'll just pull in the idle. I'm not sure if, yeah, I think there will be 2 of them, and we'll need to use this one. Just change the name for the state just so it's more readable. And yeah, we'll need jump at some point, so I'll just drag jump as well and run for the movement. So I think we could do a blend state, but I think it's better to have a simple FSM because it's not very complicated, the animation in this one. So I'll just quickly make a float, I guess, movement vector. This will basically see whether the player is moving, moving on the horizontal or the vertical axis, and if it is greater than a certain value, it would go towards the run state. So I'll just put it for 0.25 for now and disable the exit time. That way it will transition faster. That's 0.25. And we might as well add the animated trigger for jump. Now we can transition into the state from either run or jump, run or idle, my bad. So I'll just make a transition from each of them, and as usual disable the exit time and add the trigger. And that's looking pretty good. So we can go to the Playmaker FSM that we can create. Name player, add an FSM. Before I do that, I usually unpack it and then make a prefab later on. That's easier because I don't want to every time to override for the prefab. I usually do that, but it's a personal choice. You can ignore that. So just call this movement. So I'll use this action called getAccessVector, which is a little bit different from getAccess. GetAccess basically just takes horizontal or vertical or whichever axis you have mapped inside your project settings. Input an axis. So whichever you've configured here, you can access it within getAccess. In getAccessVector, it's almost the same, but you can map it relative to a particular game object. In this case, we'll be using the main camera. So I'll just store this vector, call it move vector, and name this move magnitude. And I'll set the animator float. Now I'll set the we have not assigned the animator here, and that's why it's not showing up. So I want to quickly change this movement vector name. Instead of movement vector, I want to name it magnitude, because the intensity of vector is what we are looking for. So vector has a direction and magnitude has a scale in which like the vector moves. So if I press my WASD keys, even if I go in the negative x-axis, it would still read it as a positive value, and it will just record the intensity of how much I'm going towards that direction. So I'll just store that as the move magnitude, which we are getting here. We'll just add a damp time of 1 and let's see if that's looking good. Now we need a capsule collider for this player and a rigid body. So I'll just quickly add one. It's easier if you like go to the different orthogonal modes in order to make the colliders. And I'll quickly add a rigid body as well. So I don't want the player to rotate on the x-axis, which is like this. And we might also not need the z rotation for now. If we need it, we'll enable it later. But I'll just drag the capsule collider first and then rigid body. So that's how the order should be, usually. And I'll assign the move vector to the translate position. Just leave it like this and let's just hit play and see if it works. Now let's quickly save the scene. Now the player seems to be going up, and that's because the root motion was enabled. And also you can see the animation is getting stuck. That's because I've not changed the idle. If I go to idle and edit the animation, I'll just need to loop time and pause. The same goes for the run animation as well. And once we do that, we can just retry. And I forgot to Unity disable the root motion. I think we can get rid of the damp time. And you can see that if I stop moving, it would also stop the animation. It's looking fine, but the player is not turning towards where it's going. And that's something that we need. I'll just quickly see if I can increase this. And it's moving with respect to the camera. So I think a value of 5 or 6 will do. Feels more like that game. So I'll just leave it at a value of 6. Now Playmaker doesn't usually save these values, so I need to remember them. I usually open a notepad, and if there's any specific values, I just note it down in that notepad. That way I don't lose that progress of like figuring out what exact value is feeling good for the controls. Now I need to test that if I change the camera towards this side, it should move the player with respect to the camera if I press my WSD keys. And it's doing that exactly. So that's what we need. And that's the reason we are using this get axis vector and relative to the camera. So I'll just quickly make those changes. Let's see if we can use that same vector called move vector when we're moving. So the player is currently turning in the direction that we want. So I think we can disable self space, and if we change it to world space, it's working properly. So once we change the camera as well, it should use our WSD keys to move the player in that space. Except we'll be getting rid of the camera and we'll be using Cinemachine for a lot of stuff. That will be covered in a later tutorial, but in this tutorial, I think we should look at movement, and I'll just quickly add a jump state as well. So I usually prefer to do it in a different FSM. Yeah, for now I'm just getting the key down, and I'll be using the space bar. And after we add the force when we're jumping, we should look for a collision event. And that usually, if I add a tag, and let's say this is the ground tag, I would look for that ground tag and then come back to the first state. Otherwise, the player should not be able to jump. I mean, there are a few exceptions where, like in a short hike, you can collect these feathers and improve your, increase your jumping range, jumping capacity, I should say. And that is a very specific mechanic. Yeah, that is a little bit complicated. If we want to do that, like that can be done as a separate video instead of a complete series. But for the aesthetic and gameplay elements, common gameplay elements, we are going for the Nightstone game itself for now. So we need to apply force as well as the animated trigger, which we've set up earlier. It's called jump. And I'll just save my scene, hit play. Okay, I forgot to make the return transitions from jump, so that's a huge blunder. That should do it. And just quickly check if the other changes have been applied, and make sure I remove the root motion as well. Now that seems a little unrealistic. That's usually because the value is not completely right. I'll just change. Okay, I think that seems more believable. But the animation itself kind of looks a little bit weird, I would say. But we'll go with it, and we'll not focus on art intensive stuff. Like animations are something that are usually hard to get. And this is from the Kenny.nl site itself. So instead of that, you could use some other jump animations from Mixamo or any other humanoid animation libraries. And it's easier if you create a boot and call it is grounded. It shouldn't usually be a mix of these two, but I am using a different kind of approach, I would say. And I'll just turn this to false once we jump, and we'll re-enable it once the player hits the ground. And that way we can add the other condition here where the grounded is true. Okay, another issue here is the exit time. If I remove the exit time, I think that should be fine. Usually if you want to like have a even more high quality like prediction of like when to transition into the idle from jump, you would do a recast, and depending on the recast you would check whether the ground is near to the player or not, and based on that you would transition into the idle state. That's a little more advanced for this game we're making, so I'll just leave it at that. And I think we can decrease this to 100 and we can just make them variables. Instead of doing all this, you can just create a variable called jump force, and in the variables you can just click on input and you can set that here. This is just trial and error. You would do this a lot when you're making your game, and you'll arrive at a value which feels good, and it should resemble your entire game's aesthetic and the setting. So I think we've arrived at a nice controller. Except the run animation is a little bit too fast. I would quickly change that. So 0.75 maybe. It looks a little bit too dramatic, but I think it's fine. It's just a cartoonish kind of look to it. So I think we've reached a good point where we have a good system for the movement, and the player can run around and jump and navigate, and it looks all clean. So I think we can stop here, and in the next tutorial we'll be looking at dynamic cameras. We'll be introducing Cinemachine